Alright, this is section 10.5, independent and dependent events. We'll start with an independent event. It says the outcome of an event does not affect the outcome of a second event. If I'm looking at a formula here for probability of A and B, the probability of A multiplied by the probability of B will tell you the probability of both. Remember, if it's independent, the outcome of the first thing that you do does not affect the second thing that you do. Here is an example of this. I have a spinner here and I have a quarter. What I spin on this spinner does not affect whether I flip heads or tails on that quarter, so that is considered an independent event. So we take the idea, it says you spin the spinner and flip the coin. What's the probability of spinning a prime number and flipping tails? Well, you're told here the probability of a prime number. There are three numbers there, 2, 3, and 5. Remember, a prime number is the only thing you can divide by is 1 and itself. And there are a total of 5 numbers. So the probability of spinning a prime number is 3 out of 5. The probability of flipping tails is 1 out of 2. So I'm going to multiply those two together. 3/5 is the probability of spinning a prime number, and I'm multiplying that by 1/2. So the probability of doing those two things is 3 out of 10. Alright, a dependent event. A dependent event is the outcome of an event that does affect the second event. If I want to, again, know the probability of two things, I find the probability of the first one. Then I find the probability of what B is after A, and you'll understand that better when I do the next example. Just remember, though, on a dependent event, after what you do the first time will affect what you do the second time. Alright, this example is a little tricky, but we'll get through it here. It says people are randomly chosen to be game show contestants from an audience of 100 people. So that is our total number we have. You're with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first, then one of your friends? Well, if you look here, probability of relative, pretty straightforward. There's 5 of your relatives, and there's a total of 100 people. So it's 5 out of 100, which of course we can simplify down to 1/20th. So that's the probability of that. The probability of then your friends being chosen, well, you've got to think about it. There are 6 of them total, so that's 6. Now this is how it's a dependent event. After one person has been chosen, we no longer have 100 people there. We have 99. So the probability of the second thing there is 6 out of 99. Of course, we can simplify that down to 2 over 33. So again, a dependent event, the first time we have 100 people, the second time we were down to 99. So it changes the second one. So let's then find the probability of the last example. We ended up getting 1 out of 20 was the probability of your relatives, and the probability of your friends was 2 over 33. So when I go ahead and I multiply these, I'm going to first simplify to make my life easier. I'm going to reduce this by 2 is 1, by 2 is 10. And when I multiply straight across, it gets me 1 out of 330. So what's the probability of first your relative getting chosen, then a friend, is 1 out of 330. Obviously not very good odds if you think you're going to see that happen on that game show. Again, what's the point here? A dependent event. What happens the first time is going to affect the second one. Alright, 4 practice problems for you here tonight. I would like you to read these and tell me if they're independent or dependent. And we don't always do a good job of this. Please explain why. It doesn't have to be anything fancy, but you have to explain why you answered independent or dependent. I will look over those tomorrow. Have a good night.